It's loud, it's powerful, and it rules the forest. The chainsaw has revolutionized the logging industry by replacing simple muscle power with mechanical might. The chainsaw can fell a tree and quickly turn logs into lumber. Production begins with the plastic housing. 3 aluminum inserts must be molded into the housing to provide solid anchors for other parts. A robot picks up the inserts one at a time and delivers them to an injection molding machine. Then, it places the inserts into a mold at the front of the machine. The machine injects melted plastic into the mold to make the chainsaw's engine cover. During the molding process, the metal inserts become integrated into the housing. It takes just seconds to transform these plastic pellets into a chainsaw engine cover. The robot carries each engine cover to an automated cutter that removes any unwanted bits of plastic. The scraps drop into a bin below. The hot covers cool for about 10 minutes. Then the robot moves them to the next station. There's one more piece of plastic housing, the fuel tank. The sonic welder melts and fuses it to the engine cover using high-frequency vibration. Now it's time to move on to the engine and install a spring system for the starter cord. The 2-stroke engine slides into the plastic casing, and a spark plug is popped into place. After the crankshaft is lubricated, the chainsaw's automatic oiling system is installed. The carburetor is attached, along with the pull cord starter system. The saw gets an air filter. Then the chain bar's stud bolts are dipped in adhesive and screwed into the inserts molded into the plastic housing. The rear handle goes on, along with a safety release trigger. The front handle is screwed into place. And the oil line gets a filter attachment that lubricates the bar and chain. That will strain out any impurities. Next, workers install bearings and the crankshaft clutch system. The clutch is the link between the engine and chain. When it's engaged, the chain will move around the cutting bar. The engine is now ready for a test run at typical speed, 8,000 RPM. Technicians adjust the carburetor so that it mixes the right amount of gas and air, and check the exhaust to make sure it doesn't exceed pollution standards. Workers attach the company's logo and other operational information. Then the brake system goes into place. Finally, the metal bar and chain blade are packed in a protective sleeve. Once the saw's chain blade is installed, the owner has a power tool with teeth for almost any job. People associate cheesecake with New York, but actually, it comes from Greece. The ancient Greeks served this rich delicacy to the athletes of the first Olympic Games in 776 BC. The Roman conquest spread the dessert across Europe, and many centuries later, European immigrants brought it to North America. The ancient Romans even brought cheesecake to their temples as an offering to the gods. The basis of a cheesecake is its rich, creamy filling made from ricotta, Neufchâtel, or cream cheese. But first, bakers need to make the crust, similar to a butter cookie. For a batch of about 5 dozen cakes, this bakery combines 50 pounds of butter with 10 pounds of sugar. Next, 16 egg whites. Then, 25 pounds of flour. After mixing just long enough to incorporate the flour smoothly, a conveyor belt shuttles the dough to a vat. Gravity pushes the blob of dough through a slot at the bottom, expelling a sheet less than a 1/4 inch thick. A dusting of flour prevents the dough from sticking, not just to the conveyor belt, but also to the rolling and cutting tools. This prickly roller perforates the dough sheet. The holes allow any trapped air to escape during baking, which prevents the dough from shrinking and ensures a flat, bubble-free crust. The next roller has plastic circles that work like cookie cutters, slicing the dough into cake-sized discs. The leftover pieces go into new batches of dough. Each dough circle goes into a pan, then bakes at 375 for 16 minutes. Meanwhile, the batter starts taking shape. For a batch of about 20 cakes, the bakery combines 25 pounds of cream cheese with 2 pounds of cultured sour cream. That sour cream processed a little longer than usual to give it extra flavor. After slowly mixing in 15 pounds of sugar and about 2½ cups of flour, workers blend in 3/4 of a cup of vanilla extract. Now they get cracking with 1½ dozen eggs. That's the recipe for plain cheesecake. Flavored versions come with extra goodies. This batter is caramel pecan. It's paired with a chocolate cookie crust. As the baked crusts arrive, sprayers grease the inside of each pan with butter so that the cake will slide out easily after baking. Then a machine called a depositor shoots in just the right amount of batter. The pans now enter a tunnel-shaped oven that's almost 25 yards long. The temperature inside is a toasty 350 degrees. By the time the cakes exit the other end, they're fully baked. These 10-inch cakes take just under an hour. From the oven, the cheesecakes go onto a cooling conveyor. And by the time the hot cakes do the nearly hour-long circuit, they're at room temperature and ready to come out of their pans. From there, most cheesecakes go straight into the storage freezer, but there are a few exceptions which detour to the decoration department. This Belgian chocolate cheesecake isn't complete without a big squirt of chocolate ganache, a decadent mixture of chocolate and cream. Workers spread it all over, then make swirls with a decorating comb. And now the final touch, a sprinkling of cocoa. Some cakes go into an automated cutting machine that divides each cake into 14 equal slices and inserts parchment paper in between them. Back at the decorating department, they're putting shards of chocolate on a mud pie, a combination chocolate souffle chocolate cheesecake with pecans and coffee mousse topping. You might want to put off that diet just for one more day.
A Cine camera is the type of camera they use for making motion pictures. It captures what it shoots on 16 or 35 millimeter film. Running like a well-oiled machine, its intricate components work with ultimate precision, all inside a powerful marvel of technology and craftsmanship. The internal mechanics and electronics of a Cine camera perform an impressive choreography to capture images. To make the main housing, a computer-controlled milling machine cuts precise spaces in a block of aluminum. Then a probe scans it so a computer can verify the shape meets engineering specifications. Next, a variety of computer-guided drills and cutters shape the film gate, the component that holds the film for exposure. A grinding wheel completes this highly precise task. They buff the film gate on a rotating drum, infused with diamond powder and a polishing compound. Next, workers apply glue to the film guide, which pushes the film into the film gate. Then they put glue on the film movement, mate the guide in movement, then drive in screws to secure the bond. These two registration pins hold the film in place. Now for the pull-down claws. Workers mount these aluminum devices inside the film movement, one on each side. They move forward and downward as the registration pins retract, dragging the film along the guide. As the claws pull the film down, the pins enter. This exposure repeats at a rate of 150 frames per second. Next, workers screw on a cover to protect the movement's fragile parts. Another cover fits on the other side. Workers then test each of the buttons. Now they attach the camera's drive shaft. The motor drives the movement using a toothed belt. A mechanic's test comes next to ensure the claws and pins perform with precision. This part of the camera is the shutter. It sits between the film and lens. Workers mount a mirror over half the shutter. The mirror reflects the image into the viewfinder when it rotates in behind the lens. A dab of special cleaning fluid yields a pristine surface. Any dirt on the mirror would create a fuzzy image. The protective cover plates will shield existing openings. Here, the shutter and mirror spin in unison. In this model, the shutter is electronic, so it requires a tiny microchip and electrical wires with plugs on the ends. Technicians scrutinize the parts and connections. Then they test the electronics again to ensure everything is working, starting with the shutter. With all the internal components complete, it's time to install them in the camera's housing. The film gate we saw earlier snaps into position. Next, technicians carefully mount the film guide behind the film, then fasten it tightly. Last but not least, the shutter gently slides into position. They close up one side of the housing with a cover to protect the circuit board inside. Workers then lay an accessory controller gently into the camera's side cover. It takes tweezers and a steady hand to insert this focusing screen through the lens mount at the front of the housing. Finally, the lens takes its place front and center. With the camera structure now complete, workers attach a magazine containing the film. A little nudge here and there leads the film down the right path. The movement swings forward to allow the film to run its course. With a touch of a button, the film successfully races through a mechanical maze. This camera excels at high speed and special effects. All it needs now is some action. Clay pipes are part of a major underground network, one that's dedicated to proper drainage. We flush without thinking, but it may surprise you to learn that clay pipes have been serving us well for thousands of years, ever since the days of ancient Babylonia. They're the sanitary sewer system's oldest secret. These pipes can take a lot of stress. They bear the weight of soil and structures overhead, and they won't corrode. They start with scrap clay from manufacturing, raw clay, and shale. After these materials have been roughly processed, a loader scoops the mix onto a conveyor that takes it to a mill for a finer grinding. At this point, the mix has about 10% natural moisture, but it's not enough for it to stick together. So they add more water as it falls into a mixer. The mixer evenly distributes the water in the mix, then moves it towards an extruder that pushes the clay through a pipe-shaped die. The clay pipe that emerges is 7.8 inches in diameter, the size that typically serves a residential side street. It has a bell-shaped opening. It's the female part of a joint that will fit to the male end of another pipe. A rotating blade trims away the ragged edges. Then an automated system loads several pipes at a time onto a rack to await the next step. Over on another production line, they're making flue liners for chimneys. The clay is fairly soft at this point, so lettering wheels easily engrave information, and they can cut it to size using only a thin wire. An upender lift stacks it on a pallet to await further processing. Elsewhere in the plant, a main trunk sewer pipe is born. With a diameter of over 15 inches, it's big and needs a substantial trim job to get rid of the rough edges. It weighs well over 660 pounds, nearly 5 times that of the residential pipe. Once they're fabricated, every clay pipe goes into a big dryer for at least 24 hours. A trip through a kiln will toughen them up even more. They'll spend about 50 hours in here, exposed to very high temperatures. This step is called vitrification. It fuses the mineral particles together. They tap each pipe with a hammer to test it if it's solid, and perform a thorough visual inspection. To join lengths of pipe together, they pour polyester resin into the female joint molds that have been placed in the bell-shaped pipes. The resin hardens, forming an O-ring, and the primer brushed on earlier helps the new resin joint adhere to the clay pipe. Next, they make a male joint by pouring resin around its spigot end. This will make for a joint with a tight seal. They test the joints by pumping water into the pipe. Then they raise it as they place a load on the joint. How much pressure will this joint take without failing? Over a ton, which more than meets industry requirements. Now they do another type of test on a basic clay pipe. A hydraulic jack applies pressure on the pipe. The number on the gauge far exceeds the burden of being buried underground. And so these pipes are now ready for civic duty down in the sewers.